So how do we write balanced chemical equations? So these are the instructions, and they may or may not make much sense, and then we'll do a bunch of examples. So the first thing we have to do is write a skeletal equation. We need the correct chemical formulas. That's really important. You have to have the correct chemical formulas to start with. So you write the reactant formulas and an arrow and the product formulas, and you get all your formulas correct. You may have to look back at chapter 5 if you're a little rusty on that. And then we need to start balancing. And this is a technique called balancing by inspection. And the book is going to give you some suggestions here, and they're just suggestions. So if an element occurs in only one compound on both sides of the equation, balance it first. If there's more than one such element, balance metals before nonmetals. Some equations are harder to balance than others. If you get a hard one, then these guidelines can be important. Because for those tricky ones, which element you start with may make it harder or easier. So that's just a guideline. Another guideline, if an element occurs as a free element on either side, balance it last. And this is probably the most important one. If you've got like oxygen or hydrogen or helium or something on one side all by itself, if you leave that for last, you can fix that element without messing up anything else. If when you're done balancing, if you have coefficients that are fractions, you need to turn those into whole numbers. And you do that by multiplying the entire equation. And we'll see an example of that. When you're finished, or when you think you're finished, check and make sure that it's balanced. Add up the total number of atoms on each side and make sure it's equal. And here are two important points. Do change the coefficients. Those are the numbers in front of the formulas. Do not change the subscripts. Don't change the actual formulas. It can be really tempting sometimes, but you can't do that. So here's an example, first of several. Write a balanced equation, chemical equation, for the reaction between solid copper and solid sulfur to form solid copper 1 sulfide. So the first thing we have to do is write the formulas for these different reactants in the product. This is a sentence with words, and we need to change it into or interpret it as a chemical equation. So we've got solid copper and, so that's like the plus, solid copper plus solid sulfur to form, that's where the arrow is, copper 1 sulfide. Well, solid copper is just an element, so I'm going to put S in parentheses because they told me it was solid. That suggests that they're wanting me to include state symbols. Is copper a diatomic element? Horses need oats for clear brown eyes. No, it isn't. So it's just the element symbol. Solid sulfur. So sulfur is capital S. It says it's a solid, so I'm going to put a small s in parentheses. Is sulfur diatomic? No. So those are my reactants, and I left some space here because there's a good chance I'm going to have to put a coefficient in here. So always leave a little space in front of your formulas. There's my arrow. Copper 1 sulfide. Okay, so I'm just going to do a little scribbling up here. Copper 1 is Cu plus. Sulfide, I know from the periodic table, is a 2 minus. And I look at those, plus 1 minus 2, and I could do the crisscross thing and end up with Cu2S as my formula. The formula for the compound is based on what we learned in Chapter 5. This is an ionic compound, and so we're going to use the charges to predict the formula. We do not decide on the formula based on how it makes the equation balance. So the formula for the product, Cu2S, I'm going to put solid because I was told that. Now I'm going to balance it. This is a simple one, so we'll just kind of look at it. A lot of times you can just start on the left. So let's start with copper. How many copper atoms are on this left side of the arrow? 1. And on the right side of the arrow, there's 2, right? Cu2. That's not balanced. That means we need to have some more on the left side. So the way I do that is I put a number 2 in front of the symbol for copper, saying that I have 2 atoms of copper reacting with 1 atom of sulfur to form 1 molecule of Cu2s. So I've got 2 coppers here, and I've got 2 coppers here. How about the sulfurs? How many sulfurs on the left?
1.
And how many on the right?
1.
So I'm balanced, and that's one balanced equation. Any questions? Let's do another one. Write a balanced equation for the reaction between sulfur dioxide gas and oxygen gas to form sulfur trioxide gas. So sulfur dioxide, that's S, oops, let's see if I can get it straight this time, SO2. The di means 2, and it says that's a gas, so I'm going to put G. And that's reacting with oxygen gas. Oxygen is a diatomic element, and so I'm going to write O2, not O. And that's a gas. And that forms, what's the formula for sulfur trioxide? SO3. And it tells me that that's a gas. So now we look at this, and we have to balance it. So I have 1 sulfur on the left side, and I have 1 sulfur on the right side, so that's good. On the left side I have 2 oxygens here and 2 there, total of 4. On the right side I've got 3. Well, I could put a 2 here, but I'm still going to have too few over here.
You could put another 2 there. That would change that.
I've put a 2 here.
And then put a 2 in front of the SO2.
So if I put a 2 here, I can't change the 3. It'd be so easy to just make the 3 into a 4. But I can't do that. So when I've done this, now I have 6 oxygens on this side, right? And I've got 2 plus 2 on that side. So this one's getting a little bit complicated, isn't it? I'm going to show you another way, a more write it out way. So chemical equations are a little bit like a balancing act. Okay, so here's a teeter-totter. And we need to end up with the same number of S's and O's on each side of the teeter-totter. And so one way we can do this to keep track of it, and this can be really helpful when you first start learning how to balance equations, and then later you won't probably have to do it anymore. So I listed here the different elements that I have, that's an S and O, and then I'm just going to kind of take an inventory of what I've got. So in SO2 I have 1 sulfur and 2 oxygens. And in O2, I have 0 sulfurs and 2 oxygens. And then I'm just going to add these up. 1 plus 0 equals a total of 1 sulfur on the left side, 2 plus 2, 4 oxygens on the left side. Then over here, I've got 1 sulfur and 3 oxygens. Well, let's get rid of that 2 first, because that wasn't there originally. And I don't really have to add those because there's only the one thing. But if I look at these and compare them, I've got 1 on 1 for the sulfur, so that's okay. I've got 4 and 3. That's not okay. So if I put a 2 here, I need more oxygens on the right side. And the only thing I can do is add more SO3s. So I put a 2 in front of the SO3. That changes the number of sulfurs to 2 and the number of oxygens to 6. And it kind of looks like we made things worse, doesn't it? Because now the sulfurs are messed up too. And we say, well, okay, I screwed up the sulfurs, let's fix those. I can fix the sulfurs by adding more sulfur on that side by adding another SO2. So that gives me, from that compound, 2 sulfurs and 4 oxygens. Do you see what I'm doing? Now that's going to change our totals. Now I've got 2 here plus 0 is a total of 2 sulfurs on the left side altogether. And I've got 4 plus 2 is 6. Now I've got 2 and 2, 6 and 6, and it's balanced. Any questions? Sometimes it looks like some weird voodoo or something, but it actually isn't. Let's do another one. Write a balanced equation for the reaction between aqueous hydrochloric acid and solid manganese 4 oxide to form aqueous manganese 2 chloride, liquid water, and chlorine gas. I'm going to leave the state symbols off this one because I know from experience this morning that it's really hard to fit it all on the screen. So pardon me for that. Okay, we need formulas. Hydrochloric acid, HCl. Hydrochloric acid is a binary acid. It's hydrogen and one other ion, and so that's HCl plus manganese, that's not what I meant to do, manganese 4 oxide. So let's, on the side, or on the top here, let's write out the ions. Manganese 4 is manganese 4 plus, oxide is O 2 minus. This is one of the few situations where doing a crisscross thing without thinking can get you into trouble. We don't want Mn2O4. We want MnO2. If we just crisscross, we get Mn2O4, which we would have to simplify, because the ratio of 2 to 4 can be reduced to 1 to 2, and we want the lowest ratio there. So that's the manganese 4 oxide to form manganese 2 chloride. So now it's manganese 2 plus, and it's going to be combined with chloride, which is a -1. So the formula for that is MnCl2. So we've got MnCl2 and water. What's the formula for water? H2O. And chlorine, Cl2. Chlorine is a diatomic element. So there we've got our skeletal formula, or skeletal equation. So I'm going to demonstrate that whole tallying idea again with this one. So we've got hydrogen, chlorine, manganese, and oxygen. Those are the 4 elements that are in this formula, in this equation, I mean. In HCl, there's 1 hydrogen, 1 chlorine, 0 manganese, 0 oxygen. In MnO2, there's no hydrogen, no chlorine, 1 manganese, 2 oxygen. And I'm just going to add those up. 1, 1, 1, and 2. MnCl2, 0 hydrogens, 2 chlorines, 1 manganese, 0 oxygen. H2O, 2 hydrogens, no chlorines, no manganese, 1 oxygen. Cl2 has 0 hydrogens, 2 chlorines, 0 manganese, 0 oxygen. I'm just going to add these up. I'm going to write them over here on the left because it's just more convenient to have all the numbers in the middle where you can compare them easily. So here I've got a total of 2 hydrogens on the right side, 4 chlorines, 1 manganese, and 1 oxygen. So these are the guys I'm going to be comparing. Is this equation balanced? No, those numbers are really different. So let's start at the top. That usually works. If you start at the top and things start to get ugly and you feel like you're just going around in circles, just start over and start with a different element. One of the guidelines was that if you have an element all by itself, like we do with chlorine here, it recommends leaving that for the end. And so what I'll do is I'll do the hydrogen. I'm going to skip the chlorine because I can always fix that one at the end. If I put a coefficient in front of anything else, it changes 2 elements. If I put a coefficient in front of the chlorine, it only changes the chlorine. Do you see that? That's why you might want to leave it for the end. Okay, so for hydrogens, I've got 1 on the left and 2 on the right. So I need to make there be more on the left. You can't, or I'm not going to show you how you would reduce the number. We're only going to increase. So this one's smaller, so we need to increase that. Put a 2 in front of that. That gives us 2 hydrogens and 2 chlorines. And then I'm going to adjust the total in here. So that's a total of 2 hydrogens now and 2 chlorines. Let's skip the chlorine for now and go to manganese. Oh, well, the manganese is already balanced, isn't it? 1 and 1. Then let's look at the oxygen. We've got 2 oxygens on the left and only 1 on the right. So that means we're going to have to go in here and make more oxygens on the right. The only one that has oxygen is the H2O. So I'll put 2 there. That'll change the hydrogen to 4 and the oxygen to 2. And then I'm going to go fix my totals here. Now I've got 4 hydrogens and 2 oxygens. Now I fixed the oxygens, right? I fixed the oxygens, but I messed up the hydrogens. Sometimes it feels like we're going around in circles. So we got to go fix the hydrogens. Well, I need to get rid of this 2 then. And I want a total of 4 hydrogens on that side, so I need to put a 4 there. Now I've got 4 hydrogens and 4 chlorines. So I'm going to fix up this total here. 4 plus 0 is 4, and 4 plus 0 is 4. Ta-da! So that one, we kind of went around in a circle a couple times because we fixed the hydrogen, then we messed it up, and then we fixed it again. If you find yourself going around in circles and it seems impossible, double check your formulas. If you have a formula that's incorrect, it may be impossible to balance. Any questions? Here's another one. Write a balanced equation for the reaction between liquid benzene. They're giving you the formula because we haven't learned how to write the formula for that one. Gaseous oxygen to form carbon dioxide and liquid water. So the reactants are C6, let's stick with the yellow. C6, H6, and the state of that one is a liquid. Reacts with gaseous oxygen. Oxygen is a diatomic element, so we have to put O2 to form carbon dioxide, CO2. It doesn't give us the state. It doesn't specify a temperature. If no temperature is given, assume room temperature. What state is carbon dioxide at room temperature? It's a gas. So they're hoping that you know that now. And liquid water, H2O. Okay, so I'm going to draw a line here so that I can compare the right and the left. I'm going to make a list on the left of the different elements I've got, carbon, hydrogen, and oxygen. In C6H6, I have 6 carbons, 6 hydrogens, no oxygens. In O2, I have no carbons. I'll write this over a little bit. No carbons, no hydrogens, 2 oxygens. I'm just going to add these guys up. 2, 6, and 6. Then over on the right, CO2, I've got 1 carbon, no hydrogens, 2 oxygens. H2O has no carbons, 2 hydrogens, 1 oxygen. Adding these up on the left this time, 1, 2, and 3. So these are the numbers that I'm comparing right in there, the totals. And nothing's right, is it? Let's start at the top. How can I fix the carbons being imbalanced?
Two on the C6H6.
Well, if I put a 2 on the C6H6, then I'm going to get even more carbons on this side. I'll have 12.
It'll be uneven though.
Pardon me? Yeah, I have 6 carbons on the left side right now, and I only have 1 on the right. So I need to be adding carbons to this side.
The oxygen will come out uneven.
Yeah, but then you can just add.
But we'll fix it. We're just going to go one element at a time. So I'll put a 6 here in front of the CO2. And so that'll change this to a 6, and this will change to a 12. But then my total in here, I get 6 hydrogens. And my goal was to straighten out, 6 carbons. My goal was to straighten out the carbons. So I straightened out the carbons. But now the hydrogens are still messed up. I've got 6 on the left. I need there to be 6 on the right. This water molecule has 2. How many water molecules do I need to get 6 hydrogens? 3. Because 3 times 2 is 6. So if I have 3 water molecules, then I've got a total of 6 hydrogens and a total of 3 oxygens. You follow? So that changes this number and this number. 6 plus 0 is 6 hydrogens. 12 plus 3 is 15 oxygens. And don't be afraid that that's a large number. It happens sometimes. My carbons are straight, my hydrogens are straight. I'm going to go fix up my oxygens. I've got 2 on the left and 15 on the right. What's the problem here? What do I multiply 2 to get 15? 7.5. I've got an odd-even problem. I need an odd number of oxygens on the right side, but the oxygens are only coming in pairs.
You need to put a 2 in front of C6 and H6.
What we're going to do is we're going to double everything, because when we double an odd number, it becomes an even number. So this is one approach, is just to double everything that we've already done. I'm going to leave the O2 alone for now, because we haven't done anything to him. And that's what we're going to use to fix everything up at the end. So I'm going to go through and I'm going to put a 2 here, which is going to double everything down here. And I'm going to leave that O2 alone. I'm going to change this 6 into a 12 and this 3 into a 6. Now I've got, I'm going to have to use the eraser. Now I've got 12 carbons and 24 oxygens from the CO2. I've got 2 times 6 is 12 hydrogens and 6 oxygens. Okay, the numbers are getting big, but it's okay. So what do I have here? I've got a total of 12 carbons on the right, 12 hydrogens on the right, and 30 oxygens. I need to fix these totals too. On the left, I have 12, 12, and 2. By doubling those, I didn't mess up the carbons and the hydrogens. Now, I need an even number of oxygens. The oxygens are still coming in pairs. How many pairs of oxygens do I need to get 30 individual oxygen atoms? 15. So I put the number 15 as the coefficient, and that changes this to 30. And now my equation's balanced. 2 benzenes, 15 oxygens, forms 12 CO2s and 6 waters. Any questions?
Can you leave it up there for a second?
Mm-hmm. It'll be on YouTube also. There's another way to do this that involves a fraction. So I'll show that to you as well. Okay, so I'm going to start this over and show you a slightly different way. So C6H6 plus O2 going to CO2 and water. So the whole tallying up, writing everything down may be really helpful to you at the beginning, but hopefully after you get the hang of it, you won't have to do that all the time. So I'm going to look at this and do a lot less writing. So I'm going to start over here. Here I've got carbon. I've got 6 carbons there, and I look over on the right side, and there's only 1. So I want to put a 6 here, and now I've got 6 carbons there and 6 here. And then I'm going to go to the hydrogens. I've got 6 hydrogens over here. I've only got 2. If I multiply that by 3, I'll get a total of 6 on each side. So far, so good. Now I have to do the oxygens. On the left side, I've got a total of 2 oxygens. Over here from the CO2, I've got 12, and from the water, I've got 3, so I've got 15. And over there, I've got 2. I need there to be 15. If I multiply 2 by 15 halves, that is equal to 15, right? So I could put a fractional coefficient in here. I could put in 15 halves, or if you're more of a decimal sort of person, you could put in 7.5. I'm going to stick with the fraction. This equation is balanced, but the coefficients include a fraction, which we would rather not have. So now is what one of the steps said about clearing the fraction. What can I multiply 15 halves by to get a whole number? 2. So what I'm going to do is I'm going to multiply the whole equation by 2. You have to multiply all the coefficients. So let's do this in a slightly different color. So this is going to become 2. It was a 1. When I multiply this by 2, I get 15. When I multiply 6 by 2, I get 12. And when I multiply 3 by 2, I get 6. And so I arrive at the same coefficients. Any questions? With these combustion reactions, is probably the most common place where you'll end up with that odd-even problem. So one way is this way I just showed you, to use a fraction and fix it, and then clear the fraction. Or you can recognize, hey, I've got an odd-even problem. If I double it, it will go away.